Hello, Chem 1B. This is Chapter 20, Lecture Video 1. And Chapter 20 is about really nuclear chemistry and radioactivity. And this is partly my research background, so I really enjoy this chapter. My research back in the day when I did research was on recycling nuclear waste. So this chapter holds a place in my heart. So let's continue on. So before we can really talk about nuclear chemistry, we really need to go back and review our atomic symbols, which is our kind of notation for an isotopic symbol. If you remember that isotopes are elements that have the same number of protons and electrons, but different numbers of neutrons. So this is the general schematic for an atomic symbol, where X here is our elemental symbol. Z is the atomic number, and if you don't remember that, that is also equal to the number of protons. And A here is our mass number. Well, the mass number is equal to the number of protons plus the number of neutrons in the atom. So this is the general schematic for an isotopic or atomic symbol, and you kind of need to know all about that. And you should have learned about it in Chem 1A. So all of this is what I just said. So let's talk about some main subatomic particles. There are three subatomic particles that you should have learned about in Chem 1A, and they are the proton. It's in the nucleus. Now, you might not have learned about the isotopic symbol or the symbol for a proton, which is this 1,1 lowercase p. And we're going to need to know about these because a lot of nuclear chemistry involves symbols and stuff like that. So the neutron is another one, which is 1 for the mass number of 1, and 0 because a neutron isn't a proton, lowercase n. And the electron is the third subatomic particle you probably learned about already, which doesn't have a proton, so we use this -1, E, and it doesn't have really any mass, so 0. So these symbols you should know for these three different subatomic particles. All right, so one of the big questions is, what is radioactivity actually? I mean, we hear a lot about radioactivity in popular culture and in the news, and coming from a scientist in this field, I can tell you most of the time, nobody really knows what they're talking about. Generally, when you hear about nuclear power, radioactivity, what have you, you see something like this, right? With this really scary guy in this like full body suit, carrying something glowing, that you're going to die from, and it's very negatively connotated. And this can have a bad effect on nuclear power. And nuclear power is greenhouse gas free. I mean, it doesn't affect global warming or climate change, and it is super efficient and actually has a really good safety rating when compared to other sources of power. So what is radioactivity actually? This negative, scary connotation goes back a ways, and usually primarily back to when the Cold War was occurring, because everybody's really scared of a nuclear explosion. So much so that I don't know if you've ever gotten an MRI, but MRIs are actually NMRs in chemistry, and that stands for nuclear magnetic resonance. And they changed the name to MRI instead of NMR back in the 80s due to, in part, some of their patients being really scared of the word nuclear. So what is it actually? Radioactivity is the emission of subatomic particles or high energy electromagnetic radiation. And high energy electromagnetic radiation is just light, right? That's another name for light. And this happens via certain atoms. Usually if you have an unstable nucleus in your atom, it will emit a subatomic particle or electromagnetic radiation to become more stable. The sun does this constantly. It's where we get our light from. If you've ever gone to the beach, you have subjected yourself to high energy electromagnetic radiation. It's what caused your sunburn. If you've ever gotten an X-ray, X-rays are high energy electromagnetic radiation, and it can be damaging, right? That's why they say to only get one chest X-ray every 5 years. And partly chest X-ray versus legs and other limbs is dangerous because of the organs in the chest that are very sensitive to radiation. But that doesn't mean don't do it. Like with everything, small amounts of radiation is not going to kill you. In fact, just living next to somebody or living with somebody, sleeping next to somebody every day subjects your body to more radiation than somebody that lives alone for their entire life. Because our bodies do give off a small amount of radiation. Now, does this mean you should go away and become a cat lady? I don't know. It depends on if you like cats, right? But or a cat person, I should say. But at the end of the day, radiation shouldn't be as scary as I believe the public gets from the news and popular culture. So here's some radiation in perspective, right? If we look at this, living the minimal amount of radiation you need to be exposed to get any type of cancer risk in a year is 10,000 millirem, and rem is a unit of radiation. Just to give you some idea, some perspective on how much that actually is, if you go and get a CT scan at your doctor, that's 1,000 millirem. Just every year as you eat food and water, our food and water, generally, some of them are slightly radioactive, like bananas have a radioactive isotope of potassium in them. And so you get about 30 millirem per year. That doesn't mean you should stop eating bananas. They are very good for you. Medical x-ray is around 10 millirem. Living next to a uranium mine for a year will get you about 7 millirem a year. A New York round-trip flight from LA is going to give you 5 millirem because you get higher up into the atmosphere and you're subjected to more radiation due to that. And living next to a nuclear power plant is not even 1 millirem a year. So this fear of nuclear power is, I am slightly biased on this for sure, but most of the time unfounded. The real fear comes from when there is a meltdown at the reactor, and this has very rarely happened over the last almost 70 years that nuclear power has been around. We've really only had 3 major incidents, and one of them was caused, in Fukushima by a tidal wave and an earthquake, and the government was actually warned about it not being safe prior to that, and they didn't want to spend the money to make it safe. And then in addition, 2 Mile Island and Chernobyl are the other 2 major incidents, and they were both caused by people doing things they shouldn't have been in the reactor. Otherwise, it has been going safe for the vast majority of nuclear power plants. Anyways, so if you have any questions, let me know. We'll talk more about this in the next lecture video.